So we're first going to start off with Ashish from Caltech, talking about a specialized alert broker for Romain time domain science.
Good morning, and thank you for sticking around for the last session. Also, very sorry that I missed the first 3 days of the conference, in particular the time domain part in which this should really have fit, but, well, I wasn't here, so couldn't help it. I was at another meeting. But welcome. So we're going to talk today about Arandu, a specialized broker for Roman. And the reason we're calling it specialized is because there may be other brokers that will get adapted from ZTF LSST to Roman. Some think that they will do that, but this is the first one that is going to be completely fresh. And it's a state of the art. And one of the main things that we would like to do is get feedback from you. What is it that you would like to see? We do all the standard things, of course, but also what is it that you will be needing from that. So get in touch with us with whatever you would like to know. So it is being developed in Brazil. Glacio Bohm is the PI of that, but there'll be a bunch of people from here in Pasadena and Rio, the CBPF group, who will be developing that. All right, so I'm sure you have been saturated with what Roman is the last 3 days, so I don't have to repeat this. But again, I'll simply emphasize that there are multiple surveys, there are multiple filters, there are different cadences, so the depths are different. So the kinds of alerts that we are going to get are going to be very varied. They are not going to be of one type. And so one of the things that will happen is that we'll be flooded with them, and the rapid group will be adding things like real bogus to that, star galaxy classification to that, but actual classifications are not part of rapid. And that is one of the things that we'd like to do. And that's where, again, we try to use different kinds of inputs, cross-matching, etc., in order to do that. Just to give an example, this is how HLTDS looks. And the size of the images here is less than about half arc minute. And typically in low density areas, you see a few objects in the field. But the same area, GBTDS, is going to show a very large number of objects. And that's why the density that we'll see is about 2,000 alerts per SC in GBTDS, and in HLTDS it will be a little less than that. But again, the variety would be great, more galactic versus more extragalactic and so on. And we'd like early characterization as early as possible. Plus the templates will be developed anew. So all that will be happening as part of rapid, but the classification part will be developing that further as we go along. So what is it that Arandu will do? That's where Arandu really comes in. So what we have is a lot of cross matches. There are already many sky surveys that we are pulling together, and I'll mention some of the visualization with which this gets tied. There'll be characterization and classification, because many times doing classification early immediately is not possible. You have to characterize first. So we'll have probabilistic classifications. We'll carry multiple probabilities rather than putting something in a specific bin, be able to say that what we have is likely to be this with certain probability, possibly this with certain probability, and possibly what kind of additional observations is going to resolve that. And again, inputs from you as to what kind of classes to include beyond the standard will be very useful. Plus, we'll have confidences because of all of these things, and comprehension in terms of interpretability and explainability. So when we give a certain result or a certain probability, we'll be saying why it is that much or why the models think it is that much, and it will evolve as we go along. And so it's going to be modular, and it's the first Roman-only broker, and we hope to also complement it with other brokers that may be doing something different, make sure that we provide as comprehensive capability and coverage as possible for various different areas that we are interested in. So this is the broad flowchart, if you will, how it looks. So initially we have ingestion of rapid alerts. We'll be using the Radius DB, which is hot in memory store. By the way, Gabriel from CBPF is here. In the back there, he's been developing some of this already, and I'm sure some of you have talked to him already, but he's the one who can answer more detailed questions about these nitty-gritties of these details also. And then we have got various science models. That's where the classifiers, etc., come into picture, cross-matching, etc. Filtering, we'll have API access, there'll be bulk access, you'll be able to do your own filtering, you'll be able to store various queries on that, so it's easy to rerun and all that. Again, getting early what kind of queries you'd like to do will help us also design that in a much better way. And then we'll use Parquet files because, again, bulk storage, it's good with that. Kafka topics, that's what's been used by many brokers already. And AI scope, this is the visualization part and the cross-matching part, which I'll likely touch upon later, but happy to talk in more detail later on as well. And then we'll use engines to do the various query-related things, etc. And finally, you, the scientist, will be able to do all kinds of queries using API bulk downloads, etc. A little bit more details here. So the incoming alerts will be from Rapid, and it'll be real time, it'll be high volume. Again, with GBTDS, it'll be more, HLTDS slightly less, in some other areas even less perhaps. But again, that'll vary depending on filter, etc. The storage will be hot, and it'll be in memory, so you'll be able to do many queries very clearly and fast in that way. And there'll be pre-processing that will happen. So Rapid will provide, as I said, real bogus, but it will not strip alerts, because there'll be some where maybe even they seem initially somewhat bogus, maybe real, and so we want to be able to do that. Downstream training may be using that. So here what we'll be able to do is allow people to have thresholds so they can easily separate out what are thought to be bogus, and then you can have your own thresholds, for instance. If you want really pure samples, you can set the threshold as high as you want, and you can get only the purest samples, for instance. So those kinds of things will also be possible. And then again, classification, characterization, that would happen in many different ways. There'll be binary classifiers as well as multi-class classifiers, and we'll use light curves and images and all kinds of additional cross-matching thing that you can use from there. We'll also have special things for solar system objects, because if we have all solar system objects in that, it's not easy to separate the real alerts, so we'll have separate SSO module there as well. And then there'll also be some simulations. So initially, even before Roman, we are starting to inject OU 2024 into that, the Open Universe simulations, but there'll be other simulations that will be injected. And even when Roman is observing, we'll have some simulations where things can be improved as we go along. So here's an example of classifier, and Ayush, maybe some of you talked to him earlier. Ayush, is he here? He's preparing for his final surf talk today. He was here for the summer. And the final talk is at 1:40 today. If you want to hang around for one more Roman talk, it's in the same building in room 125. So he's the one who developed this classifier, which we are called RUBRAT. It'll be on the next page, I guess. So it also uses images, PSFs. And again, right now it's using simulated data, of course. But the way we are designing it is that it has domain adaptation. So we are using multiple surveys. You start with Open Universe 2024, but test with other injections. Train with the injections and test on Open Universe 2024. The reason is that you prepare it this way, then that model can be directly used on real Roman data, because then you can do domain adaptation with real data so that we can hit the ground running and improve our classification as we go along with that. And so right now already for this GBTDS, we have about 0.95, 0.97, etc., various number recall, etc. And so there, again, when the real data comes in, there will be surprises. So initially it may not be immediately at this level, but the way it's designed is that soon by injecting small number of real transients, we should be able to get up to speed to that very soon. And this is what I had mentioned earlier, that where we are using the interpretability, where the model is focusing, that will tell us what is it that it's looking at and whether we need to tweak it a little bit, etc. And we'll be doing more of the variable subclassification. We are just starting on that. There weren't enough of those data in the Open Universe 2024. They were only explosive events, but now they are being put here. So Robbie here has been putting some of those, and we have those details now, and that's what's going on. And there will also be transient subclassification, again, from Open Universe 2024 data, but some of the ones that we may be injecting ourselves as well. So this is a broad how the current RUBRAT classifier looks. We start with the science reference and difference images. There are rotation invariant classifiers, and then we are using attention-based fusion networks so that the two can come together and they attend to each other, saying where the attention should be paid, and then we get the classifiers from there. And then, so this I already mentioned, it's paying attention to that. These are just some details how it is. So we are paying attention to how the performance is with respect to filter as well as depth. We do expect as the depth increases and we find fainter objects, the classifier is going to be slightly worse, but understanding why, where, etc. will take us there. So doing it with both GBTDS as well as HLTDS, training from one, testing on another, and all that. And so one of the things that we are looking at with ZTF is why, when we take observations and number of alerts, it's of the order of 100,000. but scientists end up looking at only a small number of them finally, about 1,000 or so. So what is happening in the middle? So understanding that will help us reduce the number of alerts that we have. So rather than flooding you with large number of alerts, if we could characterize them early on and say, these are alerts that are like of mundane objects or not of very high, possibly outlying kind of objects, etc., then it'll be easier for many researchers to ignore a good fraction of the alerts that come in and pay attention to a small number of them. And again, I already mentioned that we'll have bulk data, alert streams, science-enhanced queries. And so quickly about the AI scope part. So here we already have many different data sets. Cross matches will be available that you'll be able to get to that easily. And these are the kinds of things that you'll do. So AI scope already exists without the Roman data, of course, but with some other data sets. So you can experiment with it right now. And what it has is this query tool, cone search, image and file collections, interactive viewer, history and dashboard, and all that. And with Roman data also, all of that will be available. And the kinds of questions that you can be asking will be related to transient and variable science, star, QSO, galaxy separation, also foundation models and training sets, and photometric redshifts as well. So all kinds of variety we are trying to bring in, but again, we'd like to know more of the things that you would want to include in that. And so this is the team again, and this is where you really come in. We want your help. You can contribute, you can collaborate, or just ask us questions. Either of those would be fine. And I'll leave you with this summary slide. So saying again that Arandu is a Roman-only broker. We'll ingest alerts, we'll have cross-matches, characterization, classification, and redistribution, and advanced visualization as well as filtering. Thank you.
Thank you very much. Questions? In the back. All the way back.
I have a question about the cross-match you showed using AI scope, but I'm wondering if I'm ingesting a Kafka alert stream, will there also be cross-match information in that, or do I need to be in the portal and then deciding what I want to cross-match to?
Right, so there will be some cross-matches that will already be available, but then if you want to bring in additional data sets that are not in there, there would be two ways of doing that. Either you do it on your own, or if it is a big data set, you could also inform us and we try to get it incorporated so that it's useful not only for you, but for everyone else. So it will be both ways that would be possible.
Okay, do we have other questions? Right here in the middle.
I had a question about how you will continue the training of the new data, and will this just continue throughout the duration of all of the imaging, or will you stop at some point, and on what cadence will you kind of retrain your models for classification?
Yeah, so we would be doing retraining, and it won't be necessarily a very continuous process. It will be at certain time frames. And one of the main things that will happen is that once you have enough number of data, so light curves from real data that are reasonably long, and there would be some with only a few points, but as that grows, or as better reference images comes in doing that. So we hope to do that at least once a year, maybe somewhat more, but the whole method will be very agile and it should be easy to redo. So for instance, we'll be making our code public and it should be possible for others to also do that. So that would be definitely updated.
Okay, let's give him another round of applause. Thank you very much.